यस, गुड मॉर्निंग स्टूडेंट्स। देखिए आज हम नया चैप्टर शुरू करने जा रहे हैं, दैट इज द वर्क, पावर एंड एनर्जी। तो हेडिंग देंगे वर्क, पावर एंड एनर्जी। देखो वर्क पावर एनर्जी में हम क्या कर सकते हैं। देखो इस चैप्टर के अंदर हम सबसे पहले डिस्कशन किस चीज पे करने वाले हैं। वी विल डिस्कस द थ्री थिंग्स फॉर एनी गिवन मोशन, दैट इज द वर्क, पावर एंड एनर्जी। नाउ सबसे ज्यादा हम इस पे जो काम करेंगे, सबसे पहले हम काम करेंगे वर्क पे। हमने ये तो देख लिया कि अगर कोई भी मोशन हो रहा है, वेदर इट इज अ रेक्टिलिनियर मोशन, वेदर इट इज अ सर्कुलर मोशन, उस मोशन के अंदर कोई ना कोई फोर्स लगती है या फिर फोर्सेस आर एक्सर्टेड। हमने उनकी काइनेमेटिक्स भी पढ़ ली, उन मोशन की डायनेमिक्स भी पढ़ ली। नाउ वी वांट टू रीड दैट इज द वर्क डन बाय ईच फोर्स इन द गिवन मोशन। नेक्स्ट वी विल रीड द एनर्जी। एनर्जी जैसे यहाँ पे काइनेटिक एनर्जी, पोटेंशियल एनर्जी, किस सिस्टम के अंदर वो कंजर्व है, किस सिस्टम के अंदर चेंज हो रहा है। एंड लास्ट टर्म इज द पावर दैट वी विल रीड इन लास्ट। So today I am starting from work. Now what is work? देखो, a work is done by any force on a body if the body is moving from one position to another position. Work is done by any force on a body if it displays from one position to other. If it displays from one position to other. So work depends on force and displacement of a body. Now, अगर मैं भी इसको लिखना चाहूं तो वैसे वर्क इज राइटन एज लाइक दिस। W इज रिप्रेजेंटेड वर्क विच इज रिटन एज फोर्स वेक्टर डॉट डिस्प्लेसमेंट वेक्टर। Now, first, next, it is a scalar quantity. The unit is joule. What is its unit? And its dimension is ml to t minus 2. Dimensional formula is ml to t minus 2. Now, the next thing is it depends on angle between displacement of a body and force acting. Angle between displacement of a body and the force acting. Now the next thing is, it is work is written by each force acting on a body whether due to it body displace or not. Right? Next. Types of work. First is called positive work. If angle between force and displacement of a body is acute, then work is said to be positive work. Theta from there, then you can say in this case its displacement is in this direction and angle is positive, less than 90, so it is work is positive. Negative work, angle between force and displacement of a body is obtuse. Theta greater than 90 degree. Then work is said to be नेगेटिव। मान लो हमारे पास ये चीज है, its displacement is in this direction and force is acting opposite to it, which is making an obtuse angle with it. So it is the angle is this. Zero work. When force is acting perpendicular to the displacement of a body, then work done by a force is zero. Displacement is in this direction. mg is acting downward and normal action is acting upward. My normal action is zero. Right? Next is work done by constant force. When a constant force is acting on a body, such that its magnitude and direction is not changing. Then work is directly written as F dot ds over the whole displacement if the force is constant. we can define it directly, right? Now that is the work done by variable force. If a force is acting on a body such that its magnitude or direction is changing with displacement, then write down it. लिखेंगे इसको प्लीज. Then we will write a small work. That is dW. So dW will become F vector dot ds vector. Now let us consider F vector is fxi cap plus fz k cap. Write down it. Yes, so it is fxi cap plus fyj cap plus fz k cap. And let's go the differential displacement. ds vector is dxi cap plus dyj cap plus dz k cap. So what is the work done now? What is dw work? dw work is f dot ds, which will become dx I cap, that is fx dx I cap, fx dx plus fy dy plus fz dz. That is dw. Now if we want to calculate the total work, what is the total work? dW is fx dx plus fy dy plus fz dz. So what is the total work? Integrate it. Let's suppose I am integrating it from point x initial comma z initial to x final comma y final. So it will become dw. The integration of dw is, let's suppose, w. That will become integration of fx dx I cap 2, that is x I cap 2 plus integration of fy dy plus integration of fz dz. That is x initial to x final, y initial to y final Z initial to Z final. So this is the total work done. Clear? So in this way you can calculate it. Now one more thing. Graphical interpretation of work. Now what is the graphical interpretation of work? We know dW is F dot ds. So what is the total work? W, that is integration of F dot ds. So work done by a force is the area bounded by force versus displacement graph. Area above x-axis is taken as positive and below x-axis is taken as negative. मान लो ये ग्राफ है फोर्स वर्सेस डिस्प्लेसमेंट. This area is taken as positive. This area is taken as negative. Right? Area bounded above principal axis taken as positive and below principal axis taken as negative. Now next, प्रॉब्लम देखेंगे अब इसके ऊपर. A force is acting on a body due to which its displacement small x changes with time small d as x is equal to t cube by 3. Calculate work done by force in first 1 second. Now what is the solution for that? X is t cube by 3. So what is V? It is t square. What is A? dV by dt. What is dV by dt? It is 2t. So acceleration is not constant, it is a variable. Now, what is the force? बॉडी का मास लिख रहा हूं 2 kg m into a 2 into 2t 4t and force is also variable. Now F is 4t and X is t cube by 3. So 3x is t cube, t is F by 4. So F cube is 64 into 3. $192x. So what is that? 192 raised to the power 1 by 3 x raised to the power 1 by 3. So what is work? Integration of, you can write fx dx. It will become x raised to power 1 by 3 का इंटीग्रेशन क्या होगा? Now where is x is varying? 0 to 1 second. If you will put 0, so x is 0. he put 1, so it is 1 by 3. So you can calculate the value from there, right? Next is two forces F1 vector is equal to plus 3 k cap and F2 vector is equal to plus 9 k cap are acting on a body which cause its displacement from 1, 2, 3 to -1, 3, 4. Calculate total work done by forces. It's a force of variable constant force. For the constant force, work is directly written as. So what is F net? It is F1 plus F2. Now what is F1 plus F2? This will become I cap plus I cap 2 I cap 3 j cap 2 j cap minus 7 j cap minus 5 k cap plus 12 k cap. So work is written as F dot S for a constant force. What is S? R final vector minus R initial vector. What is R final? 2 I cap plus 3 j cap plus 4 k cap. What is R initial? I cap plus 2 j cap plus 3 k cap. So what is this? 2 I cap and minus I cap. This is I cap, this is I cap, and this is also I cap, j cap, and k cap. So F dot S, it will become 2 I cap minus 5 j cap plus 12 k cap dot with S, I cap plus j cap plus k cap. That will become 2 minus 5 plus 12 minus 3 plus 12. 3 minus 12 is 9 joule. So work done is 9 joule. Is it clear? Write down it. Next. Force acting on a body of mass 2 kg and is changing with its displacement as shown. As shown. And so on. This is the 10 Newton. This is minus 10. This is 15-20 Newton. Calculate work done by force. In 20 meter by force in first 30 meter. Now what is this? So first 20 meter में this is the area bounded. Calculate this area bounded for the first 20 meter. That will come out to be, so what is the work done for 20 meter? Half base into height. Height is how much? 10. 100 joule. First 30 meter. in first 30 meter. So for the first 30 meter, we have to calculate positive and negative area. From 0 to 20 meter minus 20 to 30 meter. It is 100 joule. And what is for this? This work is negative, half base into height. Minus 20. So it is 0 joule. Right? This is the work done for it. Write down it.